Hello there, this is Vanshika Tripathi with my ELL101 project. Let me give you an idea about how do we protect these sensitive devices from the damage that can be caused by extreme fluctuations in power supply. With that, kickstarting my project by coming to the topic. The topic that I have picked up for my project is optocouplers. The fact of fluctuations in power supply not causing any harm to devices is something that has been very intriguing for me since my childhood. But now, as I did the research for this project, I'm here to share the interesting conclusions that I got from it. Firstly, let me give you the idea about why do we use optocouplers or where is it applied. The main function of an optocoupler is to block high voltages and voltage transients so that a surge in one part of the system will not cause any damage to its other parts. And you can find them in microprocessors, used in DC and AC power control, communication equipment protection, power supply regulation, and many more. Now, let us begin the circuit diagram analysis. So here, as you can see, we have the circuit diagram for the optocouplers, wherein we have an LED, light emitting diode, a photosensor, and an amplifier, which is BGT in this diagram. We have a power supply, several resistances, and of course the output terminal. So the circuit components for optocouplers include diode, which is basically light emitting diode, photosensor associated with an amplifier, which is according to our need, and we have taken BGT in our circuit diagram, but we can obviously use MOSFETs as well. Power supply, several resistors of suitable resistances. Now we come to the main part, that is working of an optocoupler. The input circuit takes the input signal, whether the signal is AC or DC, and uses the signal to turn on the LED. The photosensor is the output circuit that detects the light, and depending on the type of output circuit, the output will be AC or DC. Current is first applied to the optocoupler, making the LED emit an infrared light proportional to this circuit going through the device. When the light hits the photosensor, a current is conducted and it is switched on. When the current flowing through the LED is interrupted, the infrared beam is cut off, causing the photosensor to stop conducting. An amplifier is basically used to amplify at the output end according to our need. With that, I would like to give a little bit more about optocouplers. Just to share more about what all I have got through in my research on optocouplers, here is some schematic diagrams of different types of optocoupler. We have phototransistor, photo-Darlington, photo-SCR, photo-TRIAC. Coming to an end of my project, I have given the bibliography on this slide, wherein I have presented all the references that I took for this project. And I would like to thank you at the end for sparing your time and giving heed to what I said.